Next talk is Celia Fuentes from ICN2. And her talk of today is entitled Paper-Based Sustainable Biosensors.
Good afternoon, everyone. I'm Celia Fuentes. I'm from Urban Mercoches Groups at ICN2, and I wanted to give you a perspective, rather review perspective talk about paper-based sustainable biosensors. So this talk was thought focusing on some of the current challenges that we're facing towards environmental testing and environmental analysis as a routinary task that we need to perform in determined ecosystems. I am going to focus mostly on water ecosystems, but this can also be applied to other ecosystems that we can discuss further later. Regarding these current challenges, many of them are directly related with logistics, which involve sampling of water or other types of sample, labeling, its shipping to the facilities, and the correct transport in order to not to modify the biochemical reactions inside of a sample, so the testing is real. Other type of challenges related to environmental testing are directly related to costs, of course. There is not much funding dedicated to environmental testing, so it needs to be used as profitable as possible. And these costs are related to the expensive facilities, I mean the laboratories for performing the analysis, as well as the expensive equipment, as my colleague Liming recently said, and of course the qualified personnel and all the materials and reagents needed in order to have a working laboratory. So why paper-based biosensors? As the lateral flow that Liming showed recently, they are all based on paper, which is a simple, abundant, cheap, portable, and easy to manufacture material. And it is also ideal for the development of point-of-care biosensors. As for the lateral flow, point-of-care biosensors are those that follow the reassured criteria. They were first called assured by the World Health Organization and further improved to reassured by Peeling's group in 2019. So which are the advantages of, generally talking, of paper-based biosensors for environmental testing? Well, they are super cheap. They cost around $1 the sensor, and obviously decreased testing, decreased cost directly translates to more number of tests in a specific ecosystem. Also, paper-based biosensors allow for quick in situ testing, therefore avoiding the logistic issues we mentioned, such as sampling, labeling, shipping, having workers to do all these steps in the way, and vehicles polluting with CO2 in the way. And it also allows for real-time testing because it avoids the biochemical changes of a sample. They are also ideal to be delivered in difficult access areas or limited resources areas, such as third world countries or very isolated ecosystems. But what for can we use this kind of paper-based tests? They can be intended for a lot of different purposes, such as identification of pollutants, identification and following of the source of these pollutants, also to verify environmental quality standards, and for the monitoring of a determined ecosystems, once known, which is the status of this ecosystem. And as for the paper-based sensors that we can use, this is the one that my colleague Liming recently explained, is the lateral flow. So I'm not going to go in deep about its mechanism, but it is a very versatile tool, as we all have seen very quickly by adapting to the COVID pandemic. There are a lot of other examples already published about lateral flow for environmental related targets, such as pesticides, pathogens as the pathogen that Liming is detecting in her lateral flow, but also heavy metals and other pollutants. These are only some of the examples. Of course, it also allows for coupling with smartphones, which really improves the detection, the measurement of the signals in the lateral flow, therefore allowing semi-quantitative measurements. The second type I wanted to show you is the Dipstick assay. This is not as known as the lateral flow, and it is mostly known because of the urinalysis test or pH strips that we all use in the laboratory. By comparing with lateral flow, they mostly rely on chemical reactions instead of biochemical reactions, and they are just one step. This is a very simple tool, but one could envision the use of these simple tools as an everyday task in a specific ecosystem, namely a national park worker could routinarily check the conditions of a river by the use of these strips, because they already detect for pH, nitrates, and can be very easily adapted to other molecules such as sulfates or phosphates, and therefore assess the state of an ecosystem in a determined moment. The last one that I want to show you is the Origami paper-based analytical device. This is the less known of the three tests that I want to show you, but it is very original, and as the name says, it is based on the folding of the different layers, which is based on. In the different layers, there are different regions needed for the detection of a determined target or targets, because it is able to be a multiplexed test. It can measure, as far as we know now, up to 10 analytes at a time. What is interesting also about this kind of test is its versatility, since it can be optical or electrochemically read. And of course, the electrochemically read gives a bigger window to work with, but also the versatility in terms of the biorecognition elements that can be used for the detection of a determined analyte, such as enzymes, DNAs, aptamers, immunoglobulins, molecular imprinted polymers, or even cells. These three tests seem very simple, but I think that it is an easy vision to establish this as routinary tasks. For instance, I used to work for a summer in a waste treatment plant, and we received every day, every morning, up to 400 2-liter bottles of water from a lot of different wastewater treatment plants that didn't happen to have a laboratory within their facilities. Therefore, they had to be 2 enormous trucks of bottles of water to be measured, all of them in a single day, with all the rush that it involves. Therefore, I do see the possibility of avoiding all of these logistics and costs and personal working just by the implementation of this kind of tests on a daily basis. But not everything is pink color. regarding these biosensors. Obviously, the ideal situation would be to reach a zero impact situation where we are not affecting the environment by trying to fix it or evaluate it or monitor it. As you all know, paper industry is a very pollutant activity, but research is ongoing in order to minimize this effect on the effluent waters of this kind of manufacturing activities. Also ecotoxicological, ¿sí? Time? 1 minute. Okay. Also, the ecotoxicological assays are being performed in order to evaluate the effect of these pollutants in living organisms. And also, agencies like the Environment Agency are providing guidelines to the public for a correct disposal of paper-based sensors already used, and also companies like Initial Medical that are providing the service for its disposal. So, even if there is a very long path to run to get this goal, I think we can try to minimize our impact in the meantime. Thank you very much.
Thank you very much for this interesting talk. The paper is open for questions.
Thank you very much for the very nice, summary of these sensors. I would like to ask, because you have mentioned all, the good attributes of this that have a lot. Yeah. So, but I would like to ask you about what are the main challenges behind the paper-based technology.
Of course, the different sensors I showed, they are intended for different purposes, depending on the complexity of the target that we need. And depending on which sensor, there are different advantages and disadvantages, but in general, we would try, we would like to reach the point where multiplexability, it's a very established thing, and that it is able to be used in all the different platforms, such as lateral flow, which is very difficult to use in multiplexing, and also the sensitivity. Depending for which target, it can be great or it can be short, but yes, apart for this would be the general challenges, I would say. Thank you.
Any other question? I do have a curiosity more than a question. You make the point very clear of the benefit of the price and the sensitivity of your sensors. What about the Internet of Things of this kind of sensors? Do you think that they are possible connected to internet somehow, or there is no way to do that?
I think so. We do couple lateral flow strips with smartphones in our laboratory, and many other examples have been published. And I do think that, for instance, to create databases for continuous measurements of a determined ecosystem could be very useful for its monitoring and to share this data with the corresponding agencies for advice, for instance. Yes, I think that should be included in the pack for the future.
The electronics for doing that is on paper as well, or is something?
Depends. If it's electrochemical, you would only use like a device, a glucometer-like device, would say. But there are being a lot of advances by just using our smartphone, because it's a very powerful tool that we all keep in our pockets, and it has a lot of possibilities for it.
Okay. Mm-hmm. Thank you very much.
Welcome. Thank you.
Thank you. Let's thank the speaker again, please.